Hey there, if you've wanted to learn Python for data analysis, this session is going to be perfect for you. You're going to hear from data scientist and data analyst Chris Bruehl. He's going to walk you through the basics of Python and how you need to use it for data analysis. He does a phenomenal job. It's a pretty quick session. Definitely stick around and check it out. You're going to love it.
Hey, everybody. Yeah, so glad to be here. Love the responses I'm seeing come in. So I see a lot of beginners. That's good. This is really tailored towards beginners, but I also see a lot of people who, I like the quote, "I know enough Python to be dangerous." That's where I was for a long time when I first started using Python on the job. And I also see a lot of people who said, I took a couple classes, but maybe it didn't progress into me being proficient with that. And that's also where I was. Python has a fairly steep learning curve. And the curriculum that I've built is really designed for people like that, whenever we learn a general purpose programming language, it can be so easy to get caught in the weeds and get stuck in a lot of theory. And so what I've really tried to do is teach Python for people who just need to know exactly what they need to be comfortable performing data analysis. And so that's what I've really tailored these courses to, because it took me a few tries to really get comfortable with it. I had learned SQL and SAS, which is a statistical language, but moving to Python, it did take me a little bit. So let me go ahead and share my screen. We're going to start out with these slides and just kind of cover the Python landscape, understand why data professionals might want to learn Python if you're comfortable with other tools, what kind of value does Python add, as well as what a learning path might look like. We'll then jump into the basics of Python. So Python is a general purpose programming language. And as I saw in the comments, it can be very scary to a lot of people. But the real important thing is just understanding some of the core syntax, as well as the key properties like data types, how to perform things like arithmetic, write loops. And as I saw somebody, functions are very important, and that can be tricky, but we'll see an example of those in a demo as well. But once you've mastered or gotten very comfortable with the basic syntax of Python, that's when you get to have fun. We get to learn how to use the Pandas library, which brings an arsenal of analytical functions and capabilities to Python, very user-friendly. And so we'll spend a lot of time working with that library before moving on to data visualization. And so we'll take a look at both the Seaborn and Matplotlib libraries, take a look at some of the visualizations that can be tricky to build in a tool like Excel, but are very easy with some of the functions that we have available to us in Python. And we'll also look at how to build, or we'll look at an example of an interactive dashboard that is one of the projects in the courses that we put together. And finally, just a very, very brief preview of data science and machine learning with a very brief demo of linear regression. So let's go ahead and think about why we might want to learn Python. Before we do that, it's important to answer the question, what is Python? So Python is a free open source programming language that's both powerful and easy to learn. It's one of the most popular programming languages in the world. It has a lot of capabilities, including things like data analytics, which is why most of you are probably here. But it's also used in software development, game development, and has additional horsepower in the data world when it comes to things like machine learning, as well as data acquisition for something like web scraping. And if we take a look at its popularity, it's certainly among the top 2 or 3 most popular programming languages in the world. So this chart here is a metric that ranks languages based on their search results in terms of people trying to learn Python. But if you look at other metrics like number of GitHub repos or questions asked on Stack Overflow, it's always in the top 2 or 3 programming languages. And one of the reasons why, it boils down to a quote that I love about Python, which is, Python is the second best language at everything. So a lot of programming languages get created or get really popular because of a specific use case. So JavaScript, for example, is very popular for the development of like web applications. And R is a data science language that came out of statistical departments and universities. But because Python is so popular and because it's so easy to use, you'll often find that those capabilities that are developed for one language are often ported over to Python. And so what makes Python so great is that not only is it really, really strong at data analytics and data science, but it also has capabilities for a lot of other things, which makes it very flexible and is a great tool to kind of round out your skill set as a data analyst or data scientist. It gives you that ability to collaborate with data engineers or perform data engineering tasks, as well as collaborate with software engineers, et cetera. But why specifically Python for analytics? There's a few reasons. One is scalability, and I mean this in two ways. One is that because Python is free, all you need to do to roll out Python to an entire organization is make sure people download the implementation, have the same version, and there aren't going to be the same types of barriers in terms of getting licenses or budgetary approval that other enterprise type tools might have. And so that's one of the reasons why, particularly when you're looking at tech or startup companies, Python is often really high in demand for analytics roles because it's free and those companies have limited budgets. And so in that sense, it's very easy to scale across an organization and it plays well with other systems. Additionally, because Python is a general purpose programming language, it's able to harness a lot more horsepower on your machine for the specific purpose of processing data than a tool that has a graphical user interface like Excel or Power BI, right? If you use those tools with very large data sets, you'll notice performance starts to get pretty slow. And a lot of the reason why is because if you think about Excel, right, it's displaying all of the information in an interactive manner on your screen. Just displaying that information and being able to load it as you scroll through requires a lot of resources. And because Python is more under the hood, it's much more capable at big data processing, which is one of the reasons why it's so popular for data and analytics engineering. Additionally, as I mentioned before, it's very versatile. Because it's open source, anybody can develop a set of functions or libraries for this language, which means that if there's a new type of machine learning model that comes out, if there's a new web development framework, if there's a new cool type of visualization, somebody can take the time to code that up and make it part of the Python ecosystem, which means that there's tons and tons of libraries and awesome tools out there for Python users, which makes it very versatile. And kind of along those same lines, that same community that is responsible for developing all of this functionality within Python is also an amazing resource. Python is one of the most popular languages, so that means that if you ever get stuck or are trying to figure out how to use a new tool, there's going to be ample resources out there for you and forums like Reddit or Stack Overflow where you can get help when you get stuck. And of course, now with the advent of AI tools like ChatGPT, all of the articles online that were historically written about Python have been ingested by AI. And it's an absolute superpower to be able to use AI in tandem with a coding language like Python because it's very good. It has a lot of knowledge around this language compared to some more obscure languages. And so you'll find that you're able to break past plateaus very quickly if you engage with these communities and leverage AI. Another very kind of underrated use case, the sexy use cases of Python or data viz and machine learning, but its ability to automate tasks and connect disparate systems is one of the most powerful capabilities it has. So whereas a lot of tools require complex plugins or custom integrations with your database software, et cetera, it's very easy to connect Python to a database, write out to Excel. We could even email Excel files using Python. So we can automate a lot of workflows and have these really nice programs that just run, process data, perform the task that we need with either a single click or even schedule them. So we can really automate a lot of our work away and become much more efficient and make our analytics teams much more efficient. And finally, if none of those use cases are compelling, another good reason is because it is in demand on the job market, particularly in tech companies. So if you look at the job listings for data roles for Facebook or Google, I guess Meta now and Alphabet now, you'll find that they typically want data analysts with SQL. And of course, just as a caveat, Python alone usually isn't enough. Typically, just like other analytics tools, Python works best when paired with at least competency or proficiency in one other tool like Excel, SQL, Power BI, or Tableau. And specifically, I'd like to call out the combination of SQL, which is the language of databases, and Python. As a data scientist or a data engineer, you're typically, you need to work with databases. So SQL is non-negotiable. But from there, Python gives you a lot of the other analytical capabilities to perform advanced analytics that SQL might not be able to. And it also gives you that data viz and machine learning capability. And within the Python ecosystem itself, as I mentioned, we have that general purpose programming language, which is the root of everything. So understanding the core syntax of the Python language, things like functions, data types, logic, et cetera, are really important to get the most out of the amazing data libraries that Python has. Like when I started learning Python, I really tried to do as little of this as possible before moving on to that, onto like data viz and pandas. And I found that I was never that effective because I didn't understand the base language enough. And you're never going to get as much as you can out of those libraries if you kind of have a mediocre understanding of base Python. And so really important to get those foundations, which is what my Python Foundations course is all about. But once you've eaten your vegetables, as I like to say, then you can move on to the fun part, which is pandas. Again, this is an analytical library that has some data visualization, allows you to aggregate your data, read in data from multiple sources like Excel sheets, SQL files, CSV, et cetera, and write out and pass data into those sources as well. There's also amazing data viz capabilities. So Matplotlib and Seaborn allow you to create really nice static visualizations. But if you want something more interactive, Plotly allows you to build interactive visualizations and even dynamic dashboards with multiple tabs. And we'll see an example of that. But one of the biggest, magnets of, data folks to Python was its machine learning capabilities. So scikit-learn is one of the most popular machine learning libraries out there. If you're more statistically inclined or, like the types of output you get in R, you might prefer stats models. And then finally, we also have TensorFlow, which is a very popular deep learning framework and used for things like image and voice recognition. And in terms of what we offer on Maven, we have 2 Python tracks. We have a Python specialist track. This is all about getting the fundamentals for data analytics. So we start with foundations. This is, again, where we learn the basics of the Python language, functions, loops, etc. We then move on to Python and Pandas, data viz, and then finally interactive dashboards with Plotly and Dash. And so if you are an analytics professional, this is a really good track to start with. And if data science is something that you've been interested in learning, or you just want to brush up on the algorithms maybe you learned a while ago, this is a great track. This is a track that I developed with my coworker, Alice, who just gave an amazing presentation, I'm sure. But we had a lot of fun putting this together. So we start with data prep and EDA, which is all about getting your data into the right shape and format for machine learning, as well as exploring your data from that data scientist perspective for model building. We then move on to a regression course, which is all about predicting the value of numeric variables. And we have a time series component here as well. We also have a classification course, which is about predicting categorical outcomes, or will this happen or will this not happen? What's the probability of this happening? And finally, Alice picks up this track again with an unsupervised learning course, which gives you a lot of additional ways to explore your data, perform things like customer segmenting and clustering. And it's a track we're really proud of. So certainly, and I know someone's going to ask, I would absolutely recommend taking at least Python Foundations in the Pandas course before trying to jump into data science. You aren't going to start from zero. If you try to start with just data science, you'll probably have a tough time if you haven't taken at least those 2 courses from the Python specialist track. So with that said, let's go ahead and jump into our demo. Okay, and so we're going to start with base Python. This is the boring part, right? But it's actually, if you're a nerd like me, kind of fun. But at its core, right, these programming languages are fundamentally calculators. And so one of the very first things you'll learn, right, is how to perform basic arithmetic. So here I have an integer 2, I have an integer 5, and an addition sign in between. What do we think this is going to do? Well, it's going to return 7. We're just performing simple arithmetic. We could do subtraction, we can do multiplication with an asterisk, or we could do division with a slash. All pretty basic stuff. That returns a float. And of course, we also have our float data type. So 2.5 plus 2.5 equals 5. But if I were to wrap this in parentheses and use int, right, we can perform type conversion. And so these are very important things to understand. They're not exciting necessarily, but understanding the properties of these data types is critical. So here we have a text data type. We could use the print function to clean up this output a little bit, get rid of those quotes. But just like with other tools you might be familiar with, like Excel or SQL, we have a ton of amazing text functions just built into base Python. So if I wanted to make this all upper, I can just call the upper method on this string here to get hello world. You could do lower. Or if we wanted to split this on empty spaces, we could do .split, and it returns a list of the words separated by this space. course, if we wanted to get really crazy, we could pass in our own custom separator. So if I split on that W there, we now have hello space, then world.
Chris, any chance we could zoom a little bit? A few people asking about Zoom.
Is that better?
Yeah, I think that's a lot better.
Yeah.
Thanks.
And so, the first part of that course is all about just learning how to work with these data types. These are the building blocks of everything we do, whether it's data analysis or, software development, or just processing data in some way. Another very important data type is the Boolean data type, right? True or false. And so in order to assert whether something is equal in Python, we use two equal signs. So here I'm stating that 1 is equal to 1. Is 1 equal to 1? Yes, that means we return true. But if I were to pass 1 is equal to 2, that would return false. And so this type of statement is what allows us to build conditional logic. So if 1 is equal to 2, we'll print Chris is the best instructor. Otherwise, this else statement here will print Chris is the worst instructor. And so because 1 is not equal to 2, we print Chris is the worst instructor. So I'm going to go ahead and fix that and make it 1 equals 1. And we get the output that we know is correct here. But that's how we build logical blocks and, take one action if a condition is met and take another action if a condition is not met. If you've come from SQL, your case when statements, if, then, else, that should probably feel pretty comfortable there. The other fun thing about Booleans is they also have arithmetic properties as well. So if true is equivalent to 1 in arithmetic and false is equivalent to 0. So if I have 2 plus 2, that's going to resolve to 4. And then I'm going to multiply this by this logical statement here. Because this is true, this will return 4. But if I were to change this to 0, we would get 0 because this entire term resolves to 0. And so we have all of these data types, these building blocks, and a little bit of conditional logic. But what really makes programming languages powerful is the ability to store things in variables, right? So here I have a variable called investment value, and I'm going to assign the value 10,000 using a single equal sign. I then have a variable interest rate, which is equal to 0.05. So what I'm going to do is multiply my investment value, which is 10,000, times my interest rate, which is 0.05. And I'm going to assign this to this variable interest earned. And so 10,000 times 0.05 is 500. So what's going to get stored in this interest earned variable is 500. And of course, the other very powerful and important property of variables, and if you're coming from other languages, this might seem a little too easy, but it's very easy to overwrite variables in Python. So we're going to take our original investment value, which is still 10,000, add the interest earned, which is 500, and overwrite our investment value to get 10,500. And so now what's stored in investment value is 10,500 because we overwrote this with the sum of our original investment value and our interest earned. And that opens up the door for us to do things like write for loops. So we're going to reset our investment value back to 10,000. Our interest rate is still 5%. And then we're going to say for every month in this range, this is really just saying we're going to run this 12 times here. We're going to calculate an interest earned, just like we did before. But then we're going to add the interest earned to our investment value to get a new investment value. So every time this runs, we're going to be adding our interest to our investment value, which will allow us to compound that interest. I'm also printing out the value of our interest each month, as well as our final investment value. And so now what we see is that this ran 12 times. So in month 1, we earned $500 worth of interest. Our investment value at the end of that period was 10,500. The next month, we earned a little bit more interest because we were compounding on a higher value. Then we get 11,025, and so on until month 12 when we earned $855 in interest, and we ended up with a final investment value of 17,958. And I know that 5% per month is a very good interest rate. We might think about this in terms of years, but ultimately, that's how we perform iteration is through this type of loop. We set the number of iterations to 12. We perform these operations and we're able to run this compound interest. But where things get really powerful in terms of programming is the ability to define custom functions. So here I'm defining a function called investment calculator. And this allows the user to pass in an investment value. So we don't have to fix our value at 10,000 or change this, every time within the code itself, pass in an interest rate and pass in the number of time periods. So now we're going to set a loop that's based on the number of time periods the user enters, calculate the interest, and then overwrite that investment value to include the interest. And then we'll return the output of this function is going to be the investment value after this number of time periods. So if we run this again with the same parameters that we just did, 10,000, 5%, and 12 months, we end up with the exact same value, so 17,958. But if we want to change any values, let's say we had twice as much starting capital, we can do that. We could modify the interest rate, or we could double the length of time, and we end up with a lot of money. I wish I could do that with my normal investments. Just change those parameters and increase them. But one of the very powerful things about functions is that you can share these with coworkers, you can reuse them multiple times. And so if you have a really good block of code that you've written, you can turn it into a function and reuse it, which will make you much more efficient on the job. And it's very straightforward to do in Python. But speaking of functions, that's where libraries like Pandas come into play. So because other people are interested in the same things you are, they develop entire libraries or sets of functions that have a specific purpose or task. And that's very true of data analytics. So the Pandas library is very important in Python for that purpose. And to import the set of functions, all we need to do is import pandas as PD. I have a CSV file stored at this file path. It's called diamondsprices22.csv. And then I'm going to use the pandas read CSV function to read that in. That's going to read it in as what's known as a pandas data frame, which is very similar to an SQL table or an Excel spreadsheet. I'm then storing this data set in this variable diamonds data. And if we take a look at the head of this data frame, the first X rows, we can take a look. And so here I've returned the first 10 rows of this data frame. We have the weight of the diamond in carat. That's how diamonds are measured in terms of mass. We have the quality of how it's been cut, its color. So D is the best color in this data set and J is the worst. We have its clarity. So how clear is it when you try to look into it? And then we have several different dimensions, depth and table. So how wide is the face of the diamond and how deep is it? We also have its price in dollars, and then a few other dimensions, X, Y, Z. And of course, we can always change these parameters. Most of these functions have additional options. So if I wanted to look at the first 20 rows, I could do that as well. But a very, very important function in Pandas is the info method. This gives us really important metadata on our data set. So this tells me that I have 53,943 rows or diamonds in this data set. I have 10 total columns. If we take a look at this first column here, our carat weight, this tells me how many missing values I have. So there are 53,943 non-null values. That means there is no missing data in this column. We can also see that it's a float. Our next three columns are object or text data types, and the rest of our data types are floats, except price, which is an integer here. And so with just a single call to this function, we can learn a lot about our data. Of course, a lot of the times we do have missing data, or our data types have values that they shouldn't have, so they might be read incorrectly. And a lot of what we have to learn when we learn Pandas is how to change those data types, how to fix missing values. And fortunately, that's fairly easy to do as well here. But a very fun function in Pandas as well, and this is typically the third or fourth thing I do when I read my data, is describe. So by default, this is going to return summary statistics for all of my numeric variables. So for example, the average weight of our diamond in carats is about 0.798, or about 0.8 really. The standard deviation is 0.47. Our smallest or minimum size diamond is 0.2 carats. The 25th percentile is 0.4. The 50th percentile or median is 0.7. 1.04, and then 5, which is a very big diamond, is the largest diamond in our data set. In terms of price, we can see that the average price diamond is about $3,900. The median is about $2,400, so our data is going to be right skewed. And then the most expensive diamond in our data set is $18,823 there. And if you want, you can also get the statistics for non-numeric variables. I don't always use this method, but if we look at our cut, color, and clarity, our categorical variables, we can see that there are 5 unique cut qualities, 7 unique colors, 8 unique clarity values. The most common cut is ideal, the most common color is G, and the most common clarity is slightly included, level 1. And then we see how frequent those top values were. So there were 21,500 ideal diamonds in this data set. In terms of working with individual columns, so hopefully your analysis is done there, right? You just had to report a few key statistics, you send that off, you're good to go. But usually we need to go a little bit more in depth there. So once again, for any column, we can calculate the statistics of interest just by calling our data frame name, the column name, and then asking for that metric of interest, in this case, average. So once again, we see their average diamond was $3,932. It's also very easy to perform operations between columns or even single values. So here I'm going to divide our price column by the mean of price. This will give me a ratio of each diamond to the average price diamond. And so, for example, our first diamond was $326. And so if we look at this ratio, that means that it's 8% of the average price of our diamond. Our first diamond is 8% of the average price, and our last diamonds here are 70%. Or we could divide a column by an entire column, and that returns 1 because we're dividing price by itself. But where this can be very helpful is when analyzing diamonds is, carat weight is like the weight of a diamond is extremely important in terms of how it's priced. So if we wanted to get at quality, one thing that we could do is divide price by its weight, and that would sort of give us the level of quality by weight of a diamond. And in order to store this in our data frame, we're just going to assign the output of dividing price by carat to this column price per carat. And if we run this, we can see now that we have a price per carat column. So for example, our first diamond, the price was $1,400 per carat. And the second diamond here is a higher quality. It's $1,550 per carat, even though it's because it has a better cut quality and a better clarity value. So that can help us sort of get to the relative level of quality after adjusting for size in these diamonds, which you'll see is very important. And so, for example, we can also look at our categorical variables very similarly. So again, if we look at this cut column, this is how well the diamond was cut and how beautiful it looks based on the angles and the luster of the diamond. Ideal is the most common, followed by premium, followed by very good, good, and then fair. So fair is our worst quality, and it's the most rare. And if you think about it, that sort of makes sense, because if people are doing a good job at cutting diamonds, hopefully they're not making that many low quality cuts, right? But we can also normalize this here. So if we wanted a more relative measure, thinking about those raw counts is difficult. Again, many of these methods have options like this. So we can see about 40% of our diamonds were ideal, 25% were premium, and so on. Another very important functionality in data analysis is being able to filter our data. So if we wanted to, we could use the query method. And this is my preferred method for filtering Pandas data frames because it's very similar to SQL. So what we're going to do is take our data frame and ask for all the rows where color equals E. And if we do that, we can now see that the only value in our E column or our color column here is E. And if I wanted to add a second condition like price is less than 10,000, all I need to do is say and price less than 10,000. And there we go. And you could, of course, continue to add conditions. So or another and, etc. But let's take a look at the value counts for our cut column for this subset of data. The spoiler is it's not going to be very different than the rest of our population. But if you were looking to see if color E diamonds had a different distribution of cuts, this is how we could do that. But with this subset, we see the ideal make up about 40.3% instead of 40.0% or so. Our next very important type of operation in data analysis is aggregation. That's also very easy to do and will feel pretty similar to what you do in SQL as well. So we take our data set and we group by our cut column. We can calculate the mean of price per carat by cut. And so what we see here is that our fair quality diamonds, which are our lowest quality, have the lowest average price per cut of all of our diamonds, or price per carat of all of our diamonds. And our premium quality diamonds, which are our highest quality, have the highest. So that makes sense. That looks good. The interesting thing is if we just look at price, as opposed to that measure adjusted by size, we actually see that our fair quality diamonds, our lowest quality diamonds, have one of the highest prices. So there's something going on in terms of the size of fair quality diamonds that makes them more expensive than some of our more premium diamonds. And a few ways that we can look at that, but one of them would be to look at the median price by, or the median carat weight by these groups. So here I'm going to actually group by 2 columns, cut and color. So in order to group by or aggregate by multiple columns, all we have to do is pass in multiple columns to our group by function. And then this ag method here allows me to calculate different statistics for different columns. So I'm doing the mean of price and the median of carat weight here. And so one thing that we can see is that our fair quality diamonds tend to be much larger than others. So the median weight of our fair quality diamonds is about 0.9 to 1 carats. Whereas if we look at premium or ideal diamonds, those are down near 0.5. So our fair quality diamonds are much more expensive because they're almost twice as large at the median value than they are for our more premium quality diamonds. And so we end up with a table that's aggregated by cut and color. We get 1 row for every combination. That might be challenging for you to make sense of, which is where the pivot table can be very handy. And if you're an Excel user, you're probably like, please make a pivot table, Chris. So if we call the pivot table method here, we can make the rows of our table cut, the columns color, and then the values of our cells or individual data points are going to be the mean of price per carat. And that gives us a pivot table that looks like this. And so one thing that we can see is that just looking at fair here, our price declines essentially for every value of color. So within fair quality diamonds, as the color moves from the best to the worst value J, we end up seeing declining prices. This type of table can still be challenging to look at until we add color to that, which we're about to do. But really quickly, I just wanted to show you the built-in data analysis or the data visualization capabilities of Pandas. So here I'm going to grab just columns D and J, so our best and worst color from our pivot table. I'm then sorting by column D in descending order. So I'm setting ascending equals to false, which means that our data set will be sorted by this column D with the highest at the top, lowest at the bottom. And we can take a look at this table here. So fair quality diamonds for color D had the highest price on average per carat, and ideal quality diamonds had the lowest. And if I want to throw this into a bar chart, all I have to do is do .plot.bar, and we get a nice little grouped bar chart back. And Pandas data visualization, the built-in capabilities are a little hard to customize, but if you're just exploring data as you're moving through an analysis, it's really handy. It's super convenient. But if you do want to make presentation ready graphs, that's when you really want to dive into the specific data visualization libraries. So that's where we're going to move on to Seaborn. And so here we're importing Seaborn as SNS, and I'm going to build a heat map. I'm going to throw let's go ahead and remove a couple of these commands here. I'm going to go ahead and throw just my diamonds pivot table into a heat map and apply a red, yellow, green color scale. I got a comma. And so now we can make a lot more sense of that table that we just saw. And so one thing that we can see is that our worst quality diamonds in this table, color J, tend to be like the lowest price here, as well as our fair quality diamonds also tend to be the worst quality, with the exception of this D block here. So there may be some very high quality diamonds here based on other metrics, but for the most part, we see that intuitively this makes sense. We also see that our premium quality diamonds tend to have the highest price on average. And if we wanted to annotate this, we could do annote equals true, format equals G, and we end up with these decimals. So what we can do is round our entire data frame. If we don't pass an integer to this function, or like round to 2 decimal places, we'll round to 0. And now we can see the average price per carat of diamonds of various cut qualities and colors. We could also explore these via a box plot, which is a very nice way to look at distribution. So if we want to look at the distribution of carat weight a little bit more closely, we can see that the median carat weight in our data set is about 0.7. Most of our diamonds in our 25th to 75th percentile looks like about 0.4 to just over 1. But if we wanted to understand that cut characteristic a little bit more, we could do y equals cut, and we would end up getting a box plot for every one of our cut characters or cut qualities, right? So this makes it very easy to see that our fair quality diamonds, our lowest quality, have the highest median size, whereas our ideal in particular have a very small size. And that's one of the reasons why we saw the price of our fair quality diamonds be so much higher, is because they're often much larger than our other quality diamonds. Another very fun result here is looking at a KDE plot. So if we take a look at the distribution of the size of our diamonds, Normally you would expect, in the wild, right, this sort of smooth curve. We might have a bunch of diamonds around a given size and then slowly tail off. But this is very bumpy. And if you think about buying a diamond, right, one thing you'll notice is that these spikes occur around very clean measures of carat. So our first spike is at 0.5 carats. Our second is 0.75. Our third is just past 1. Our fourth is just past 1.5. And our last one here is just past 2. And if you've ever gone shopping for a wedding ring or a diamond, you know that you don't want to buy a 1.98 carat diamond. You want to get a 2 carat diamond, or you don't want to get a 0.99 carat diamond. You want to get up to that nice clean number. And so this sort of shows us that the people that are cutting these diamonds are very conscious of that psychology when it comes to buying diamonds and making sure that they're cutting diamonds that are just past those psychological thresholds. And of course, we could break this out so we could add a different color line for each of our categories of cut. And we could end up seeing that, again, our good and fair quality diamonds, which are our lowest quality diamonds, peak around 1 carat in terms of size. But our other 3 categories, our higher quality diamonds, peak around 0.5 carats in size. And that makes sense. Like typically, larger diamonds tend to have more likelihood for different flaws and other, poor characteristics. So like premium diamonds do tend to be smaller on average. But this is a fun result here. And we have the ability to make scatter plots to look at the relationship between our carat weight and price. You can see there's sort of an exponential relationship here. I'll move through this a bit quickly. If we wanted to fit a regression line through this, we could go ahead and use lmplot. So if you like fitting trend lines through your scatter plots in Excel, you can do the same thing here with this lmplot function. So we'll compare our carat weight to price. And this just helps us solidify the relationship that we saw. Of course, we're plotting about 20,000 data points, so the scatter plot looks a little messy right now. But we can estimate the relationship, for every 1 unit increase in carat weight, how much does price go up? This is what this line tells us. But where this gets very fun is if I break out this line by clarity. So clarity is another quality characteristic of diamonds. Basically, how cloudy or how crystal clear does this diamond look? And when we do this, we will see another very fun result. So I1 means visibly included. That is, with a human eye, you can see some severe issues inside of the diamond, whether that's cracks or little pockets. Whereas IF, this gray line, means internally flawless. So even with a microscope, you can't spot issues or imperfections in the diamond. And so what this tells us is that the rate of price increase by carat weight depends on the quality of the diamond. So low quality of diamonds, as they get heavier, increase at a much slower rate than near perfect diamonds, which increase at a much higher rate. And so if we were just to zoom in, let's say at about 3 carats, our predicted price of a 3 carat I1 diamond is about maybe $12,000. Whereas if we go 1 quality level up to SI2, it's about $20,000. So the same weight could be double depending on how high of, how much further up in quality you're going. And then very briefly, I'm just going to throw this up here. We're kind of short on time because of the technical issues, but this is a data scientist delight. If we are looking for relationships between our data or outliers or any other strange patterns, this pair plot will build a scatter plot matrix of all of our numeric variables. We get the distribution of these. I've broken this out by clarity, so we have this additional color element. But if you're trying to build a machine learning model and want to explore the relationships between your variables very quickly, this is very nice because it gives you the scatter plot matrix with the call of a single function. And so that is Seaborn. It's a really powerful and handy data visualization library. I hope one thing that you're noticing is that the syntax, Python can be scary, right? But once you've learned the basics, building these charts is super easy. We pass in our data, we supply an X variable, a Y variable, and maybe specify if we want to break out by a specific category in our data. But those are really nice static visualizations we can do in Python. And if we take a look at Plotly and Dash, this is actually the final project of the Plotly course, but this is deployed as a web app. So anybody can visit the site here, cwbruehl.pythonanywhere.com. But if I was looking to go on a ski trip, right, I could filter my data down to places that are cheaper than $100. maybe have night skiing. You can see our options start to decrease. Quite a few in the Rocky Mountains of the United States. But if we go to the Alps, we have more than enough options there. And this is a multi-tab dashboard. So I could look at which resorts in North America and Canada have the highest elevation, or I could pop this over to South America and maybe look at Chile and look at the same thing here. So that's Plotly. It's really powerful, and it's a very convenient way to build interactive visualizations. And then finally, almost out of time, but very simple machine learning model here. So I'm importing stats models. I'm then creating my X variables, right? When we build a linear regression model, we want to predict a Y variable using some set of X's. So we're going to predict the price of our diamonds, which will be Y, using our carat weight. So we set up our X and Y data frames there. And then I'm just using stats models OLS function. That's a linear regression function to predict Y using my X's. And then I'm calling .fit, which fits the model on my data. And if we take a look at the summary of this data, we can see that we have an R squared of 84.9%. In other words, 84.9% of the variability in a diamond's price is explained by the size of the diamond in carat weight. So carat weight is by far the most important factor when it comes to pricing a diamond. But if we start to include additional variables like that quality, we can explain even more and hopefully get this R squared much closer to 1, which would be 100% of variability explained by our model. The other thing this output tells us is the relationship between carat weight and price. So for every 1 unit increase in carat weight, the average price of a diamond increases by $7,756. And so whether you're looking to become a data scientist or just want to add a little bit more rigor behind a traditional analysis, learning a little bit of data science can really help add to that as well. And this is what we'll cover in that regression course. So I'll go ahead and put a pin in this presentation for now. I told you we were going to cover a lot. So hopefully you are feeling just as tired as I am.
Yeah, Chris, amazing. This is fantastic. A lot of really good head nodding and oh my gosh, this is so cool in the chat while you're doing the presentation. So I know folks got a ton out of it. We were scheduled for 45 minutes, so we're a little bit over, but can we do a couple of quick questions for Q&A?
Hey there, hope you're enjoying the video. Sorry to interrupt, we'll get you right back to it. Right now, Maven Analytics is offering a deal that was just too big not to share it with you. We've got an early Black Friday sale, and you can save up to 50% off of Maven Analytics paid plans. So if you've been considering learning Excel, SQL, Power BI, Python, Tableau, and everything else that you need to become a data analyst or accelerate your career, now is the perfect time. Check it out at mavenanalytics.io. You can see the Black Friday offer in the banner at the top of the screen. You can't miss it. Again, if you're on the fence, there's never been a better time. We don't do a lot of these sales, so I hope that some people will take advantage. Now, enjoy the video. I'll let you get back to it. Thanks.
This one here is from Mohammed asking how to automate repetitive data analysis tasks. Would you use Python scripts? Would you use Jupyter notebooks? What's your general approach to trying to do something like that?
Yeah, it depends. I mean, it depends on your infrastructure. So increasingly, a lot of systems are allowing for the use of scheduled notebooks, but ultimately, in most cases, places default to Python scripts, so .py files. But if you use a tool like Databricks, or even in Maven's own internal data engineering, now we have a tool called Jupyter Hub, which allows us to schedule Jupyter notebooks and perform data engineering tasks within the notebook format. So it really depends on the infrastructure at your work and what the guidelines are. But I'd say it's a split between, nope, you need to roll up your final data processing code into a PyScript versus we have a tool or system that allows Jupyter notebooks to run on a scheduled basis.
Cool.
But
is there one way that you prefer, Chris? If you had your pick, would you want to use the Jupyter notebooks or?
Yeah, I mean, I prefer Jupyter notebooks. That's kind of my safe place, but certainly need to know how to bundle up your code into PyScripts and do that as well. It's not too hard. It's just when you're performing a data analysis, Jupyter notebooks are super nice because they have this really nice graphical interface. And so if you don't have to switch over, it's nice, but it's not too hard. And we talked about how to do that as well.
Awesome. Very cool. That's amazing answer to that. Let's see. How about this? Oh, go ahead, Chris.
I was just saying, Pete, oftentimes you develop in notebooks, but deploy as a script. So you kind of pick and choose the pieces of code that you need. Yeah.
Yeah, that makes a lot of sense. Here, this one's from Ramya. In the age of AI and automated Python coding, what key skills should beginners focus on mastering?
Yeah, so this is definitely something that I'm still learning. I would still say it's very important to understand, like, take a foundations course like the one we have, and then you still want to learn a tool like Pandas. But one area where my perspective has really changed, or one area where I would de-emphasize now that I wouldn't have in the past, is when it comes to like customizing data visualizations. So customizing data visualizations in Python is really hard because you have to memorize, as opposed to working with Excel where you can click every element that you want and format them just using like drop-down menus. You have to memorize or look up all of these small little attributes of these charts. So like X labels, Y labels, grid lines. And now with ChatGPT, right, I might build a simple bar chart and then say, hey, can you make this like these bars red, these bars green, remove the grid lines, remove the spines, add labels or text labels or data call out, and it'll just write it all for you. So I think in general, like mastery and memorization is much less important than it needed to be. You still need to know what you're doing, and you should still have an opinion on how to do it within the tool you're working with. So I still think taking foundational courses is very important, but like you don't need to have nearly the same number of reps that you would have to feel like you're getting to proficiency, because you'll know how to ask for what you need via AI, and you'll know how to like identify when maybe the AI is taking you down a path that you shouldn't go down, or is less efficient or less useful than something that you know. So you should still have opinions and still have some education, but overall, a lot of the tedious activities are much more painless with the help of AI.
Yeah, that's awesome. Such a good nuanced answer. Like, it's not the silver bullet, but it's definitely valuable. And I think your comments on like where to focus on the foundational skills, the concepts, is always going to be important no matter what. And I say same thing when people ask me the same questions about SQL. It's like same thing. You have to have if you don't have the foundational concepts, like my mom can't just go to ChatGPT and become a SQL analyst. It's just, she wouldn't even know what to ask it, right? But yeah, so really, really good one there. Let's try to grab one more. How about this one? This one's from Mohammed. What are some tips for optimizing Python code when working with large data sets to avoid memory and performance issues? And again, this could be probably a whole hour, right? Like, yeah, but
we got a real nerd in here. No, this is good. So one of the things that I talk a lot about, which a lot of courses don't within Pandas, is memory optimization. And one of the most important things that you can do if you're working with Python data frames, that like when you are starting to push the limits of your hardware, is data type optimization. So if you look at like, this is really technical, but like if you look at how much data like a 64-bit integer takes up versus how much data an 8-bit integer takes up, if you compress down your data types to the correct level and use like categorical representations of data instead of text, when you only have text as 4 unique values, you can really start to compress down the size of your data. Like the Pandas functions themselves are quite efficient. Like you'd have a hard time writing something more efficiently than the people who have developed a lot of these functions in the data analysis libraries. But where you can get much more efficient is being very careful about typecasting, data types, a lot of the nitty-gritty stuff on top of the normal kind of conceptual, should I filter before I perform a join, etc. Those are all going to be, classic ways to optimize your code. But when you work with a library like Pandas, they're typically brilliant computer scientists who are much sharper at you than optimizing a lot of the analytical functions. So it really comes down to how you organize your code and things like data type optimization. Yeah,
Chris, this was amazing. Such a good presentation. I feel like you covered just like a crazy broad number of topics and in decent depth too, like with really practical examples. So thank you so much for doing this for us. Everybody in the audience, give Chris some love, and thank you all for participating.
Hey there, I hope you enjoyed this video. This was part of our open campus event where we ran 24 sessions in front of a live audience over the course of 2 weeks. It It was a ton of fun. We did all these live sessions and we opened up our entire learning platform for free. You did not need a paid account to take advantage of all the courses. So folks could learn Excel, SQL, Power BI, Tableau, Python, etc. All the stuff that you need to learn data analysis skills and take your career to the next level. If you missed it this year, keep an eye out. We'll definitely be doing this again next year, probably again in October. We would love to see you there. And the last thing that I'll leave you with, if you're looking to take your skills to the next level right now and you've been on the fence about a Maven Analytics paid plan, we are currently running our early Black Friday sale. This is the absolute best time to pay for Maven Analytics if you want to, so don't miss out. You'll have the opportunity to save up to 50% on paid plans, which is a pretty great opportunity. You can check out all the details at mavenanalytics.io. Just look for the early Black Friday banner at the top of the site. You can't miss it. Hope that we'll see some of you there as well. Thanks for watching.